Math 2 students, it's Mrs. Robinson here again to work the practice benchmark chapter 7 with you. Let's go ahead and go over the first one. It says, find the length of the missing side. The triangle is not drawn to scale. So if you look at the side of, or this triangle, you'll notice that it's a right triangle. One side is 8 and one side is 10. If you've studied any of the Pythagorean triples, you'll know 3, 4, 5 is a common one. 6, 8, 10 would be the next one if you multiplied 3, 4, 5 by 2. So this is a Pythagorean triple. This side's going to be 6. But let's say you don't know that. You're just going to use Pythagorean theorem. A squared plus b squared equals c squared. So side squared plus side squared equals hypotenuse squared. We don't know this side, we'll call it a. And we'll say a squared plus, the next side would be 8 squared, and that will equal our hypotenuse squared, which is 10 squared. And we will have 8 squared plus 64 equals 100. Do the simple math, subtract 64 from both sides. A little algebra here. Bring down the a squared, that's going to equal 36. And to finish it out, we will square root both sides. When I square root a squared, I get a. When I square root 36, I actually get plus or minus 6. I don't care about the negative because I'm dealing with length. So a is going to be 6, just like we said with a 6, 8, 10 triangle. All right, let's go to number 2. Triangle ABC has side lengths 20, 21, and 29. Let's erase that so we can see that. Do they form a Pythagorean triple? Explain. All right, Pythagorean triples basically are 3 side lengths that work in the Pythagorean theorem, but they need to be whole numbers. Positive whole numbers is what they need to be. These are all positive whole numbers, so now I just need to make sure that they work in Pythagorean theorem. 29 is our longest side, so that will be my hypotenuse. So I need to make sure that 20 squared plus 21 squared will equal 29 squared. If that's true, then yes, I'll have a Pythagorean triple because I'll have whole numbers that work in the Pythagorean theorem, and they will be side lengths of a right triangle. So let's go ahead and check this out. If I do 20 squared and 21 squared and 29 squared, I'm going to have 400 plus 21 squared is 441. And then 29 squared is 841. Is this true? Question mark. We need to figure that out. Well, 400 plus 441 is 841. 841 does equal 841. Check. Yes. This is a right triangle, and these numbers, that does not say that, and these numbers form a Pythagorean triple. I'll just do this. They form a Pythagorean triple. Yes, they do. They are whole numbers that form a Pythagorean triple. That's how I'm going to explain that. All right, let's go on to the next one. A triangle has these side lengths, 36, 142, 147. Is it a right triangle? So I just checked to see if I had a Pythagorean triple in that triangle. Now I just need to see if it's a right triangle. Well, once again, I'm going to plug it in and see if it forms a right triangle in the Pythagorean theorem. So I'm going to say 36 squared plus, my longest side is 147, so that will be my hypotenuse. So 36 squared plus 142 squared, does that equal 147 squared? Let me scroll this down. All right, it just erased this, so let's write this again. 36 squared plus 142 squared, does that equal 147 squared? Question mark. Well, check it. 36 squared is 1296. 142 squared is 20,164. 147 squared is 21,609. If I add these together, is it going to equal this? No. Actually, let's do it on calculator. 20,164 plus 1,296 is going to give me 21,460. It's close, but not quite. So no, these do not equal each other, and this is not a right triangle. So if I ask you to explain this on the test, you're going to explain it and say, these do not fall into the Pythagorean theorem. This is not a right triangle, and you can show exactly what I've shown here. Okay, number 4 asks you to find the value of x. If your answer is not an integer, put it in simplest radical form. We have a 90, 45. This has to be 45. So what we have here is a 45, 45, 90. And when we have that, we know our special right triangle ratios. With the 45, 45, 90, if this is my special right triangle, I'm going to have a value of x, a value of x. The hypotenuse is going to be that value, that leg value times the square root of 2. So if I know across from the 45 is x, this will also be x. This value here has to be x times the square root of 2. So to figure out the value of x, I know x times the square root of 2 has to be 44. So I'm just going to set that up. X square root of 2 equals 44. And solve for x. Divide by square root 2. And I'm going to get x equals 44 divided by root 2. And that is not simplest radical form because I have a radical on the denominator, which I do not want. I can get rid of that radical on the denominator by multiplying the top and bottom by radical 2. Now when I multiply top and bottom by radical 2, it's like multiplying by 1, so I haven't changed the value of my fraction here. I'm multiplying the top and bottom by the same thing. By doing that, 44 times radical 2 will be on top. And on the bottom, radical 2 times radical 2 is radical 2 squared. The square and the square root cancel, and I'm left with 2. So that's why I multiply by radical 2, to get that radical off the denominator. We don't like it down there. All right, now I'm not quite finished because 2 does divide into 44. 2 divides into 44 and leaves me with 22. So what I have left is 22 times radical 2. And that's what x is. X is 22 radical 2. Let's see if it works. This is 22 radical 2. And if I know my ratios are x, and x times root 2, well, 22 radical 2 times root 2, does that give me 44? Let's see. 22 radical 2 times radical 2. Well, radical 2 times radical 2 is radical 2 squared, which is just 2. So this is 22 times 2, which is 44. It does work. All right, I want you guys to make sure on these, when I ask you to express it in simplest radical form, the reason we're asking you to do that is because we want you to use your 45, 45, 90 ratios here, not your sine, cosine, tangents. If you give this to me in decimal form, I'm going to think that you used, here if I have this angle, I would use adjacent over hypotenuse, which would be the cosine, because I could also solve this on a calculator by going cosine of 45 is the adjacent over the hypotenuse and solve it that way. But then I would have a decimal as an answer, not a radical. When you give me a radical form as an answer, I'll know that you used your 45, 45, 90 ratio, and I'll know that we're testing the correct thing. We're testing to see if you know these special right triangles. So please put it in simplest radical form. Okay, let's go ahead and work number 5. You set up a makeshift greenhouse by leaning a square pane of glass against a building. Always draw problems like this. Let me get my draw tool back. All right, so I'm going to do a building. Oh, let's try that and make it a little more square. All right, and I lean a piece of glass, a pane of glass like this. That's a mistake. This should read 5 feet. It's 5 feet long, and I'll fix that on your papers. And then here, it makes an angle of 30 degrees with the ground. What's the horizontal distance between the glass and the building to grow plants? So what's this distance right here? All right. Looking at this, because I'm going to round to the nearest inch, I'm not going to use my 30, 60, 90 ratios, which I can. I can use 30, 60, 90 ratios if you want. If this is 30, this is 60, this is 90. Your value across the 30 will be whatever the number is. The value across the 60 will be that number times root 3. And the value across the 90 will be that number times 2. 2 times whatever the number is. I can do that. Or here, since I'm going to round to the nearest inch, I'm going to use my sine, cosine, or tangent ratios. Since I have 30 degrees and I have the side next to it, so the adjacent side, I have adjacent and hypotenuse. So with sine, SOHCAHTOA, S-O-H, C-A-H, T-O-A, this helps me pick which I should use for my ratios. Since I have adjacent and hypotenuse, here's adjacent and here's hypotenuse, I'm going to use cosine. So I'm going to go cosine of 30 degrees equals my adjacent, x, over my hypotenuse, 5. And then I solve for x. Now here I need a calculator, and I'm going to plug in cosine of 30 degrees, and that's going to be 0.866. And then that's going to equal x over 5. And then I'm going to solve for x by multiplying both sides by 5. That gets rid of that 5, and then I'm going to multiply that by 5, and I'm going to get an approximation. So I'm going to write it down here. X is approximately, I do the squigglies, 4.3. And that's going to be in feet since I was dealing in feet. And there is my horizontal distance, 4.3 feet. All right, let's go on to the next one.
What?
Hey, bud. All right, for this one, you're going to write the ratios for sine x and cosine x. Let me get my pen. All right, so here's the angle x. For sine of x, remember SOHCAHTOA, S-O-H-C-A-H-T-O-A. That didn't give me an O. So let's look at x. If we want the sine, we want the opposite over the hypotenuse. So sine of x is going to equal the opposite side, which would be 8, over the hypotenuse, which is 16. So sine of x is 8 over 16. If you want to reduce that to 1/2, that works too. Let's do cosine of x. Cosine of x, if we look at cosine, it's the adjacent over the hypotenuse. So here's x. For this angle, I'm going to do the adjacent side over the hypotenuse. So cosine of x is going to equal 8 root 3 over 16. This also, that's a 16, this also reduces. 8 goes into 16 twice, so this would be square root 3 or 1 root 3 over 2. And you're done. All right, let's do the tangent ratios. So tangent was SOHCAHTOA, S-O-H-C-A-H-T-O-A. Tangent is going to be the opposite over the adjacent. So if we want angle x, the tangent ratios would be the opposite side over the adjacent side. Tangent of x is going to equal the opposite side, which is 12, over the adjacent side, 5. And if I want tangent of angle z, I'm going to do tangent of z is going to equal its opposite side over its adjacent side. So 5 over 12. And you'll notice these are reciprocals. All right, let's go find the value of x, round to the nearest tenth. So here's x. I have this angle and I have hypotenuse. So let's see what I have with my SOHCAHTOA. I have an adjacent and a hypotenuse. And since I have adjacent and hypotenuse, I'm going to pick cosine. So I'm going to do cosine of 20 degrees equals the adjacent side, which would be x, over the hypotenuse, which is 10. Now I'm going to solve for x. I'm going to go ahead and plug in cosine of 20 on a calculator, but let's first multiply both sides by 10 to isolate the x. And then I'm going to have 10 times the cosine of 20, and that will equal x. I can do that on a calculator. I'm going to plug in cosine of 20, making sure I'm in degrees, not radians. Multiply that by 10, and I'm going to get x is approximately 9.4. Since it asked me to round to the nearest tenth, it was 9.39, and I'm going to use 9.4. All right, I need to solve for x this time, and x is an angle. So I'm going to go ahead and use my ratios. Since I have opposite over hypotenuse, I'm going to use sine again. Sine of x is going to equal the opposite side over the hypotenuse. And since I'm solving for the angle, I need to get this x away from the sine. And I kind of teach it like this. And I'm finding the inverse sine. I'm going to undo the sine. So if you think of it like I'm inversing the sine of both sides, I'm finding the inverse sine of both sides. And that's what to the negative 1 power. It looks like it's to the negative 1 power. It is not. It means the inverse sine. Okay, so then by doing that, you're going to get x equals the inverse sine of 9 over 14. I kind of think of it like that, like you're doing it to both sides. Now this you need a calculator for. So you're going to do 9 divided by 14, which is approximately 0.64. And then you're going to go second sine on your calculator and find the inverse sine. So the second button will change it to the inverse. And you can also do that on a phone calculator. A phone calculator will have, I don't know if you can see in my little camera here, but a phone calculator, if you turn it to its side, it will have sine, cosine, and tangent. And then if you push this second button, it'll have that sine inverse, cosine inverse, tangent inverse. So it has that. You have to push the second button on a phone calculator. All right, so if I do all that work, I'm going to get x is approximately 40 degrees, and that's an approximation. Hold on a second. Okay, a tree casts a shadow 55 feet long. So let's draw a tree here. Always draw your picture. We'll just draw, here's our little tree. It casts a shadow 55. Now, if the sun was this way, it could cast the shadow this way. Or if the sun's this way, it could cast the shadow this way. It doesn't really matter. It's 55 feet long, this shadow. And it says the angle of elevation from the ground to the top of the tree. So if I'm here at the ground to the top of the tree, we need to find that angle of elevation. So we'll call it x degrees. This would be if I was at eyesight with the ground. So I'm not a little person sticking up where I have to add to the top. It's just from the ground. So if I was laying on the ground, maybe in the eyesight to the top of the tree. And it says the tree is 95 feet tall. We want to find that angle of elevation. So from here, let's see what I have. I have my opposite side and my adjacent side. So that would be tangent. Tangent of x is my opposite side, which would be 95, over my adjacent side, which would be 55. Now I need to find x, so you can think of it like I'm going to do the inverse tangent of both sides. And it would look like this. Tangent, inverse, and I do it to both sides. That's how I get that tangent away from the x. I do the inverse tangent. And I'm going to have x equals approximately, I'm going to type in the inverse tangent of 95 over 55, and I'm going to do that on a calculator. So I do second tangent on a calculator, and I would do 95 divided by 55. And I'm going to get approximately 59.93, and if I round that to the nearest degree, it's approximately 60 degrees. All right, let's go on to the number 11. Okay, so number 11 says an airplane is flying at an altitude of 10,000 feet. So I always like to do a drawing here. We're going to have an airplane and it is flying. Here's my wings. I don't know. Here's my little airplane. It's flying at an altitude of 10,000 feet. And then it's scheduled to land at an airport that's 50 miles away. So let's say this airport's here. Let's say that airport is 50 miles away. Now it might be confusing where that 50 miles would be. Would that be 50 miles from the ground or from the plane? It says it's 50 miles away, so I'm going to do from the plane. And I put feet, sorry, miles. That is important because it says miles, not feet. It's 50 miles away. Find the average angle which the airplane must descend for landing. So we're talking about an angle of depression, not an angle of elevation. So we want to know the angle that this airplane will tip its nose down for landing. So this angle right here is what we want to know, x. All right, so let's go ahead and make a right triangle out of this. Here's our right angle. We have this in feet, 10,000 feet, and this in miles. So we need to do some conversions here. Since this is in feet and this is in miles, we need to change this to feet or this to miles. I know that there's 5,280 feet, and that equals 1 mile. Okay, so I might be inclined to change miles to feet. So if I do 50 times 5,280, I'm going to get, let me calculate that, 5,280. I'm going to get 264,000 feet. All right. So now these are both in feet. Now I can go ahead and figure this out. I need to know the angle of depression here. So what I'm going to do is I'm going to use this angle right here to use my trig ratios. And once I figure that out, I know this is 90 degrees, so I'm just going to subtract this from 90 degrees to get that angle of depression, or how many, or what's the angle that the airplane would have to descend, okay, the average angle. So I have y, and what I have is the adjacent side and the hypotenuse. Since I have adjacent and hypotenuse, I'm going to use cosine. So cosine of y is going to equal the adjacent, which is 10,000 feet, and that is in feet. It's important that those are both in the same units. So adjacent over hypotenuse. I'm not going to use the 50 miles because it's in miles. I'm going to use the feet. 264, so be very careful with your units. All right, and then I'm going to go ahead and find y. In order to do that, I need to find the inverse cosine. So I'm going to do cosine inverse. I'm going to do that to both sides, cosine inverse. So I'm going to find the inverse cosine of this. So I go ahead and divide this on my calculator, and then I find the inverse cosine of this. I'm going to come up with y is approximately, let's see, I come up with 87.8. And that will be in degrees. And I'm going to round that up to approximately 88 degrees. That's what I get for y. If y is approximately 88 degrees, and this makes 90 degrees, I have 2 degrees left for here. So I know angle x is going to be 2 degrees. And that will be the average angle at which the airplane must descend for landing. 2 degrees. If he's at 10,000 feet, he has to descend that, tip that nose 2 degrees so that he hits at this airport that's 50 miles from here. All right, so 2 degrees would be the answer. Okay, none. All right, we have 3 lengths. We want to know if these 3 lengths make a triangle, and we know they're triangle lengths. We want to know if it's acute, obtuse, or right. So we know how to tell if it's right. If it's right, we would have a squared plus b squared equals c squared. And that would tell if it's right. If it's acute, meaning it's a small angle, all of them are, excuse me, not a small angle, all of them are acute. All of the angles are less than 90. You would have this, a squared plus b squared, and it's getting hard to write again. It always does this at the end of the test. All right, a squared plus b squared is going to be greater than c squared. Or what it would mean is your longest length is going to be less than a squared plus b squared. So that hypotenuse, which it's not, if it's acute, it's not a hypotenuse, but that longest length is going to be less than a squared plus b squared. And if it's obtuse, so you have your right triangle, where this is going to equal these two. That would be my right. You would have your acute triangle, where this is going to be less than those two together. And you would have your obtuse triangle. It's a really wide one. where c squared is going to be greater than a squared and b squared. So you would have this, a squared plus b squared is going to be less than c squared. C squared is going to be bigger than these two together. This side's going to be bigger than a and b. So let's check this and see what I have. Let's do 11 squared plus 13 squared. That's the next length. And then that's a 3 and that's a 2. Sorry. 11 squared plus 13 squared. What is that to 17 squared? Okay, 17 is your longest side, so that will be your C. So is 11 squared plus 13 squared equal to 17 squared? Is it greater than or less than? Well, let's check it. I know 11 squared is 121, and I know 13 squared is 169. And let's see, I don't know, what's 17 squared? 17 squared is 289. All right, so I'm just going to go 121 plus 169, and I'm going to get 290. So 290 is actually greater than 289, just barely, but it is. So since a squared plus b squared is greater than c squared, or c squared is less than a squared plus b squared, I have an acute. So I'm going to say acute. And it says explain by showing an equation. So I'm going to say I have an acute triangle, and here's how I'm going to explain it. I'm going to write out my length, I'm going to work out the work, and I'm going to show 290 is greater than this. So I have an acute triangle. So make sure you show me this on the test. All right. All right, looking at number 13, you have an escalator at a shopping center that's 200 feet long and rises at an angle of 15 degrees. So always do a drawing. If I have an escalator that goes up like this, it's 200 feet long, and it rises at an angle of 15 degrees. So from the ground, it's going to rise at an angle of 15 degrees. And they want to know, what's the vertical rise of the escalator? So this, what's the straight up rise? That will be x. So you have your right triangle here. And what we want to do here is write an equation using either sine, cosine, or tangent that you will use to solve this problem. So if I have 15 degrees and I have the opposite side and the hypotenuse, well, opposite over hypotenuse would be sine. So part A, I'm going to say, I'm going to do sine of 15 degrees, and I want to see this on the test, equals x over 200. And when you type this in, just do the slanty for the division. So just do that slant for division, and I'll get it. All right, and then part B, to the nearest foot, what is the vertical rise of the escalator? So I'm solving for x, so I'm just going to plug in sine 15 on my calculator, and then I'm going to multiply both sides by 200 to get rid of that 200 off the denominator. Multiply both sides by 200 feet. Multiply this side by 200. And then that eliminates the denominator, and I'll get 200 sine 15 degrees equals x. And x is going to be an approximation, and you should get about 52, or 52 feet. And that's the vertical rise of that escalator right here, 52 feet. And this pen gets worse and worse as the time goes on. All right, going on to number. Okay, so this one asks us to sketch, or a square tablecloth has a line of embroidered flowers along the diagonal. And it says the tablecloth is 48 inches on one side, and it's a square, so all the sides are 48 inches. So now it says sketch a square tablecloth, then explain how you'll find the length of the diagonal. So part A, I would see something like this. It's a square, and there's flowers all along the diagonal. So something like this, okay? And I lost my tool. Oh no, where is it going? Okay, so part A, I sketch my square and I have flowers all along the diagonal. How will I find the length of this diagonal? Well, if this is a square, I know each side is 48. All the sides are 48. Also, if it's a square and I draw a diagonal, I immediately create a 45, 45, 90 triangle. So in part A, how will you find the length of the diagonal? Use 45, 45, 90 ratios. It's really hard for me to write on this, but that's what you're going to use. use 45, 40, and 5, 90 ratios. Okay, it's super slow. Okay, so that's what you would say for the first part. How long is the embroidery line? Round to the nearest inch. So we want to know the length of the diagonal. That's what we want to know. We want to know this. Well, if I use my 45, 45, 90 ratios, I know in a 45, 45, 90, I have one side would be the number, the other side would be the number, and the hypotenuse would be that number times square root of 2. So if this is 48 and this is 48, this is going to be 48 root 2. So part B, how long is the embroidery line? 48 root 2. And since it says round to the nearest inch, go ahead and plug that in on a calculator. Let's go 48 times root 2 on a calculator. And I'm going to get 67.88. So I would round that to 67.9 to the nearest inch, 67.9 inches. And that is the length of the diagonal. Now this is asking us something different. Find the exact value for the sine of one 45-degree angle. Then find the exact value for the cosine of one 45-degree angle. So let's go ahead and pick any 45-degree angle. It doesn't matter. So part C, the sine of 45 degrees is going to equal, let's do this one. It will be the opposite over the hypotenuse. If I did this one, it'd also be opposite over hypotenuse. It's going to be the same. It doesn't matter. So I'm going to go opposite 48 over the hypotenuse, which will be 48 root 2. Now, I don't like radicals in the denominator. And I know 48 divided by 48 gives me 1. So I'm going to be left with 1 over root 2. And since I don't like radicals in the denominator, I'm going to multiply top and bottom by radical 2. And when I do that, it's like multiplying by 1, like we talked about before. And when I multiply top and bottom by radical 2, well, on the top I'm left with, let's do this in red since I'm running into my other work. On the top I'm left with radical 2. And on the bottom, I'm left with radical 2 times radical 2. Well, that's radical 2 squared. And the square and the square root cancel, and I'm just left with 2. So this would be radical 2 over 2. Now let's go ahead and do the cosine, part D. The cosine of 45 degrees, this thing does not like to write. The cosine of 45 degrees will be adjacent over hypotenuse. The same here. Cosine of this will be adjacent over hypotenuse. Also, 48 would be the adjacent over the hypotenuse, which is 48 radical 2. And this obviously is the exact same thing as this. So this is going to reduce to the same thing. Square root of 2 over 2. So you can see the cosine and the sine of 45 degrees is going to be radical 2 over 2 both times. And as you get later on into trig, you're going to see why this is going to be super useful. All right. Let's go on to number 15. All right. Let's go ahead and do number 15. Given the regular polygon, find the measure of each numbered angle. All right, knowing that it's regular means each angle is going to be the same measure. And since I have, let's see, how many angles do I have? 1, 2, that one's chopped up twice. So 1, 2, 3, 4, 5, 6, 7, 8. I have an octagon. And I know I have 360 degrees to divide up 8 ways. And when I do that, it's going to give me each central angle. So if I do 360 divided by 8, I'm going to get 45. I know each angle is going to be 45 degrees. So the answer for angle 1, the measure of angle 1 is going to be 45 degrees. Let's look at angle 2. Angle 2, since each of these are 45 degrees, they're all 45, and this one's cut in half. This would be the apothegm right here. It's cut in half. Angle 2 is just going to be 45 degrees cut in half. So if I take 45 and divide it by 2, I'm going to get 22.5. And that will be the measure of angle 2. So the measure of angle 2 is going to be 22.5 degrees. And it does not want to write 2's. This does not like my 2's or my 5's. Okay, so if that's 22.5 degrees, this is also 22.5 degrees. This is 90. 22.5 So 22.5 for that angle. This is 90. So that leaves angle 3. If this is a triangle, it's 180 degrees. So I take off 90, I have 90 left. Take off 22.5 from 90, and that will tell you what angle 3 is. And it is not letting me write the 2's. Okay, so when I do 90 minus 22.5, I'm going to get the measure of angle 3, which is going to be 90 minus 22.5, which is 67.5. That's a 7. All right, there we have it. Pretty easy. Now that's going to help us go on to number 16. All right, number 16, I edited and it didn't show up here, so I will fix it. This is supposed to say the area of a regular or it's supposed to say this. You're going to find the area. Because given the area and finding the side is much harder. You're going to find the area of a regular hexagon. It's not going to be 35 inches. You're going to find it, and you're going to be given the length of the side is going to be 8 inches. Okay, this is how it's going to read on your paper. So find the area of a regular hexagon given the length of the side being 8 inches. We're going to round our answer to the nearest tenth. So if we have a regular hexagon, and because I'm drawing it by hand, it's not going to be very regular, but a hexagon has 6 sides. And if it's regular, all the sides are going to be equal length, and they're going to be 8 inches. So every side's going to be 8 inches, and so on and so forth. We know we can divide, because it's regular, we can divide this into 6 isosceles triangles. And because it's regular, we're going to go 360 and divide it by 6 because it's a hexagon. And that will tell us the measure of each of these angles. If I do 360 divided by 6, I'm going to get 60. So I know every angle is 60. These are all 60 degrees. And if I drop an apothem from the center straight down, it's going to cut that in half. And what it's going to give me is a 30 degrees here. And I'm going to drop a right angle. This will be 60. If this is 30 and this is 90, this has to be 60. So I have a 30, 60, 90. That's the beauty of these regular triangles. I know to find the area of a polygon, my formula is 1/2, and you need to know this, 1/2 times the apothem times the perimeter. And the apothem is just the altitude drop from the center perpendicular to an opposite side so that you create a 30, 60, 90, or whatever it might be. In a hexagon, you're going to create a 30, 60, 90, all right? And it basically is, when you look at this, you have a triangle. It's the height of your triangle. Triangles are 1/2 base times height. 1/2 the base times the height. The height of this triangle is your apothem. So the area of this is going to be 1/2 the base, which will be your perimeter, because you have lots of triangles. You have all of these triangles. So instead of just the base, you do the perimeter times the height. So it's just the area of a triangle done this many times. That's all this formula is. All right, so we need to get this height right here. If we know each side is 8, this side is 8. And if I cut it in half, this side will be 4. If opposite the 30 is 4, remember your 30, 60, 90 ratios. You got to know those. Okay, if this is 60 and this is 30, and it's so hard to write with this. Opposite the 30 is your number. Opposite your 60 is your number times √3. And opposite your 90 is 2 times your number. So you got to know those ratios. So if we have opposite the 30 is our number, which is 4. Opposite the 60 is going to be 4 times √3. And there it is, 4 times √3. So now I have what I need. My apothem is 4 √3. And I know my area is going to be 1/2 times the apothem times my perimeter. Now my perimeter should be really easy to find. If I know it's 8 on one side and I have 6 sides, my perimeter is going to be my number of sides, which is 6. Sorry, my perimeter is going to equal, not multiply. My perimeter is going to equal 6 times my length. My number of sides times my length of the side. So my perimeter is going to be 48. And there's my perimeter. So remember, perimeter is just it's not writing very well. Number of sides times the length of a side, or just times a side maybe. The number of sides times the length of the side. All right, so there's my formula. All I have to do is plug this in on a calculator and do the math here. And the area, I'm going to do 1/2 times 4 root 3, which will give me 2 root 3, multiply that times 48. And my area is going to be approximately, rounded to the nearest tenth, 166.3 inches squared. Wow, this is writing super slow right now. It's like it gets tired. Okay, on to the next. Okay, we're going to find the area of a regular hexagon. Oh, we just did that one. Find the area of the regular hexagon with the apothem 16.5 inches long, a side 19 inches long, round to the nearest tenth. So you can go ahead and draw this one if you want, or you can just remember the formula. Area of a regular polygon is 1/2 times the apothem times the perimeter. And we have everything we need here. To get our perimeter, if we have a side that's 19 inches long, and we know we have a hexagon, the perimeter, because I have a hexagon, is going to be 6 sides, and then times 19. So our perimeter here is going to be whatever 6 times 19 is, 114. So now I have my perimeter. I can plug that in. This is 114. And then my apothem I was given. It's 16.5. And sorry for the writing. It's not working so well right now. All right, so I have 1/2 times 16.5 times 144. That's going to be equal to my area. And I just plug that in on a calculator and calculate that out. You should get approximately, after you do the calculations, you should get approximately 940.5, and that will be inches squared. So this one, you didn't have to calculate anything using the apothem and the perimeter. They just want to make sure that you know that formula. All right, let's go on to number 18. Find the area of an equilateral triangle, side length 24. A couple ways you can do this. With equilateral triangles, you can use the apothem times perimeter because an equilateral triangle is a regular polygon. However, we know some other things about equilateral triangles. If I have a side length of 24, I know the area of a triangle is just 1/2 the base times the height. I don't even have to do this whole deal, the apothem and the perimeter. I just know it's 1/2 times the base times the height, and it's not going to let me write it. That's supposed to be a 2. All right. So if I have this as 24, if I drop an altitude right here, I can figure out my height. I don't have to come from the center and do the apothem and that whole thing. I can figure out my height with the information I've been given here. And I know if I cut this right in half, because it's an equilateral triangle, I have 60 degrees here. This will be 60. This is 90 because I dropped an altitude. And this makes this 30. So I have a 30, 60, 90 is what I have. Because this is equilateral and I cut it right in half, this is going to be 12 here. And this will be 12. Now I know my base is going to be 24. Okay. Because I have 12 and 12, this is going to be 24. So I'm going to go 1/2 times my base. I need my height. That's what I need here. To get my height, I'm going to use my 30, 60, 90 ratios. And I know in a 30, 60, 90 triangle, opposite the 30, I'm going to try to draw this. This is a 60. It does not want to draw right now. This tool is awful. Opposite the 30 is the number. Opposite the 60 is the number times root 3. And opposite the 90 is 2 times the number. That's my ratio for my 30, 60, 90. So if opposite the 30 is 12, opposite the 60 is going to be the number times root 3. So opposite my 60, or the height that I need, is going to be 12 times root 3. And there's my height, 12 times root 3. Now I have what I need, and that is supposed to be a 12 times root 3. Sorry. That's all the information I need to calculate this. Now I'm going to leave it in simplest radical form. So I'm just going to calculate this. Half of 24 is 12. 12 times 12 is 144. So this is going to be 144 times the root 3. And that will be my answer. And it is meters. Since this was all meters, This is going to be meters squared. And there I have it. Okay, so this one asks me, how long is the diagonal if I have the area of a square garden? And the square garden is 72 meters squared. I know the area. I don't have to do apothem perimeter here either. I could. But I know the area is just the side squared for a square, right? So if the area is 72 meters squared, I'm just going to go 72 equals my side squared. So one side is just going to be the radical of this. Just root both sides. I don't do the plus or minus. So radical 72 is going to be one side. And I can calculate that. I can, yeah. Wow, this is really not working right now. That's supposed to be a 2. Is equal to, wow, okay. Radical 72, let's see, is equal to the side. That's one side. So I just take the radical of both sides. Now I need to get the diagonal. And in a square, if I cut the diagonal, I create a 45, 45, 90. And I just need to know my ratios for 45, 45, 90s, and I can get that diagonal super easy. If I know each side is radical 72, let's me do it. There we go. Each side is radical 72. So in a 45, 45, 90, I know my ratios are the sides are n, or the number, and the hypotenuse is the number times root 2. So if my sides are 72, my hypotenuse is going to be root 72 times root 2. With my 45, 45, 90 triangle, I'll draw it over here, and I don't know if it's going to be my number, and the hypotenuse is my number times the radical 2. Those are my ratios for my 45, 45, 90. So if I have, my sides are radical 72, my hypotenuse is going to be radical 72 times radical 2. Now, since they're both radicals, I can multiply them together. I'm going to go 72 times 2, and that's 144. So my hypotenuse is going to be the radical 144, and root 144 is just 12. So I have 12 meters, and that's my diagonal. All right, on to the last one. Find the value of the variables x and y. If your answer is not an integer, leave it in simple radical form, simplest radical form, which means they don't want you to use sine, cosine, tangent. They want you to use 30, 60, 90 ratios here. Okay, remember your 30, 60, 90 ratios. This is 30, 60. So anytime you see simplest radical form, think your 30, 60, 90 ratios or your 45, 45, 90 ratios, all right? I know this, in my 30, 60, 90 ratios, I know opposite the 30 is going to be my number. Opposite the 60 will be whatever that number is times radical 3. And opposite the 90 will be whatever that number is times 2. So 2 times the number. All right. So what we have here is we have opposite the 90. It's 20. That's what we know. So we know we have 2 times our number, and we know that equals 20. So in order to find our number, I just divide by 2, and we know our number is going to be 10. What is that number? If I divide by 2, yeah, it's so hard to write with this thing. It did not do this when I started. Okay, if I know that number is 10, remember in our ratios, the number is opposite the 30. So opposite the 30, that's 10. So now I just solve for x. X is 10. And then opposite the 60 is whatever that number is times radical 3. So if the number is 10, opposite the 60 is 10 times radical 3. Now I've just solved for y. So I have x is 10, y is 10 radical 3, and I've left it in simplest radical form, and I'm finished. All right, guys, that's it for this test. Let me know if you have any questions. I'm going to go update number 16 for you, and have a good day.